We are going to derive the power rule using implicit differentiation. So we have y equals x to the n. Our goal is to find y prime. So here's how we're going to do it. We are going to start here, and we are going to take the natural log of both sides. Okay, so we just started with y equals x to the n. We took the natural log of both sides of the equation. And our goal is, again, eventually going to be to find y prime. Well, the reason we did that is we can use the properties of logarithms to bring this n out front of this natural log on the right. So we'll keep the left side, and we'll bring down the n. So this is n times the natural log of x. Okay? And now we're going to take the derivative of both sides with respect to x. So the derivative of the natural log of y with respect to x is going to be 1 over y but then because y is a function of x, we're going to have to multiply by y prime. That's the implicit differentiation part. Okay, and then n times the natural log of x. So n is just a constant. So this is going to be, the derivative of the right-hand side is going to be n times the derivative of the natural log of x, which is just 1 over x. Okay? And now our goal is to find y prime. So we can solve for y prime by multiplying both sides by y. Okay, so we have n over x times y. Now this isn't your familiar n x to the n minus 1. We have a y floating around here. So we don't want it like this. But notice that we have y here. Our original definition was we defined y to be x to the n. So we can substitute x to the n for y. So y prime is going to be n over x times x to the n. Okay, so we have x to the n in the numerator and x to the 1 in the denominator. Using the properties of exponents, this is going to be n times x to the n minus 1. And that's our derivative.